Dear students, let us continue our discussion on set theory operations. This is video part 3 of our discussion. In the video part 1 and 2, we had discussed important points or conventions which should be followed while expressing the set of real numbers in bracket method or on number line. We also elaborated these points with the help of examples. The students are advised to view video part 1 and 2 before continuing to view this part. The link of the video part 1 and 2 has been given in the description. Now we are going to discuss how set theory operations can be carried out by tabular method and by number line method. We will explain the tabular method with the help of an example. Let there be two sets B1 and B2. Derive B1 union B2 and B1 intersection B2 by tabular method. Solution. The first step is to enumerate critical points of both sets. The critical points are -2, 2, 6.7 and -6.7. The critical points in ascending order are -6.7, -2, 2 and 6.7. There are 4 numbers of critical points, hence there are 4 plus 1 equals 5 numbers of intervals. Please note that -infinity and infinity are not considered as critical points. Since there are 4 numbers of critical points and 5 numbers of intervals, there will be 4 plus 5 equals 9 numbers of rows in the table. In the table, right mark means that interval or that point is the element of the set. Cross mark means that interval or that point is not the element of the set. This is the table in which the first column is serial number, second column is critical point and critical interval. The other 2 columns are of the given set B1 and B2, and these 2 columns are for the required set B1 union B2, B1 intersection B2. The minimum value of the critical points is -6.7, hence the first entry in the row is the interval between -infinity and -6.7. Then the 4 numbers critical points -6.7, -2, 2, 6.7 have been entered in row number 2, 4, 6 and 8. In between the intervals has been written and the last interval is from 6.7 to infinity. Please note that in the column the interval is shown with open ends and the critical points are shown as discrete points, that is in curly brackets. Also note that the intervals and the critical points are in ascending order from top to bottom. Now we are going to express set B1 and B2 in tabular form. The set B1 and B2 are written in bracket form above the table. It is very convenient if these sets are expressed in ascending order from left to right. The interval between -infinity and -6.7 is the element of set B1. Hence, a right mark is shown. The point -6.7 is the element of set. The interval between -6.7 and -2 is the element of the set. The point -2 is the element of the set. The interval between -2 and 2 is not the element of the set B1, hence a cross mark is shown. The point 2 is the element of set. The interval between 2 and 6.7 is the element of the set. The point 6.7 is not the element of set. The interval between 6.7 and infinity is not the element of the set. In a similar manner, set B2 has also been shown in tabular form. With the help of this table, we can derive the union and intersection. That interval or point which is the element of either B1 or B2 or both is the element of union also. So this is element of B1, hence also B1 union B2. This interval is this element of both sets, hence union also. This is this cross union. This is right. This is cross. This is cross. Let us now derive the intersection. That interval or point which is the element of both sets B1 and B2 is the element of intersection also. The range and this point is the element of both sets. Hence these two and the others are cross. The union and intersection has been derived in tabular form. While changing expression from bracket form to tabular form is easy, changing expression from tabular form to bracket form is tricky. For expressing in the bracket form, those intervals and points which are the elements of the set are written in ascending order and combined with the union sign. Then, with the help of some judgment, the shortest form of bracket notation is written. You can see that the tabular method is quite lengthy. As the number of critical points increases, it becomes more tiresome. By number line method, we can carry out set theory operations with ease and in less time. Let us enumerate stepwise procedure for set theory operations by number line method. Step 1. Draw a real number line and mark all the critical points of the given sets in ascending order. Step 2. Below the real number line, draw the number lines of given sets so that every critical point of the given sets is vertical aligned. The term vertical aligned has been highlighted. Below the number lines of given sets, first of all, check the status of critical points, whether they are the elements of the required set or not. Draw dot or donut as per their status. Follow vertical alignment while doing so. Step 4. Check the status of intervals and draw a firm line as per their status. Now you have arrived at number line representation of the required set. This is the end of video part 3 of our discussion on set theory operations on real numbers. In the next video, I shall explain the stepwise procedure of number line method with the help of an example. Also, I shall solve some inequality problems in which set theory operations are useful. Thanking you for watching the video. Subscribe the channel if you had liked the video. Post your valuable comments.